According to the 2014 and 2017 editions of the National Electrical Code, or NEC, type USE-2 cable is permitted for use in wet locations in accordance with Article 336.10. It is not required to be installed in conduit or other raceways for concealed wiring. However, the 1999 edition of the NEC also allows the use of USE-2 cable in wet locations, but it does require that it be installed in a raceway for concealed wiring. There is an exception to this requirement for installations in underground raceways. If USE-2 cable has been installed in Schedule 40 polyvinyl chloride or PVC conduit for a concealed wiring installation, and if operating under the 1999 NEC, this installation is not permitted. The cable should have been installed in a raceway that is fire rated, such as type RTRC or rigid non-metallic conduit. Even though the cable is installed in conduit, the conduit does not provide sufficient fire protection. To resolve this issue, it will be necessary to modify the installation to bring it into compliance with the NEC. This may involve replacing the USE-2 cable with a fire-rated cable such as type THHN or type XHHW, or installing the cable in a fire-rated raceway. It is important to note that the NEC is periodically updated, and the requirements for electrical installations can change. It is always best to consult with a qualified electrician to ensure that the installation meets the current code requirements. When working with electrical installations, several key considerations come into play, primarily focusing on safety and compliance with the National Electrical Code, or NEC. This code, updated regularly, dictates the standards for electrical wiring and equipment installation in the United States. The type of cable used, the method of installation, and the environment in which the installation occurs are all crucial factors. USE-2 cable, which stands for Underground Service Entrance Cable, is commonly employed for direct burial or installation in underground conduits. It is designed to withstand wet environments and resist degradation from sunlight and chemicals found in soil. However, the NEC places specific restrictions on its use, especially when it comes to fire safety. The NEC outlines various requirements for different wiring methods and cable types, including USE-2. These requirements are designed to prevent electrical hazards, such as fires and shocks. The code specifies the types of conduits and raceways that can be used with different cables, as well as the methods for securing and protecting the wiring. In the context of a concealed wiring installation, where the wiring is hidden within walls or ceilings, the NEC mandates the use of fire-rated cables or raceways. Fire-rated materials are designed to resist the spread of fire, providing valuable time for occupants to evacuate and for firefighters to respond. The type of conduit used is also critical. While PVC conduit is suitable for many applications, it may not provide adequate fire protection in certain scenarios. In such cases, the NEC may require the use of metallic conduit or rigid non-metallic conduit, or RTRC, which offers superior fire resistance. When an electrical inspector identifies a non-compliant installation, it is essential to take corrective action promptly. Failure to comply with the NEC can result in fines, delays, and, more importantly, increased risk of electrical hazards. The corrective action may involve replacing the non-compliant cable with a fire-rated alternative, such as type THHN or type XHHW, or installing the existing cable in a fire-rated raceway. THHN, or thermoplastic high-heat-resistant nylon-coated, and XHHW, or cross-linked high-heat-resistant water-resistant, are both commonly used for general-purpose wiring and are available with fire-resistant properties. When selecting a fire-rated cable, it is crucial to ensure that it is properly sized for the intended application. The NEC specifies the minimum conductor size based on the ampacity, or current carrying capacity, of the circuit. Overloading a cable can cause it to overheat and potentially start a fire. The NEC also addresses the issue of derriting, which refers to reducing the ampacity of a cable when it is installed in certain conditions, such as in a hot environment or in close proximity to other cables. Derriting is necessary to prevent overheating and ensure the safety of the installation. In addition to cable type and raceway requirements, the NEC also covers grounding and bonding. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding is the process of connecting metallic parts of an electrical system together, creating a low-impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shocks and minimizing the risk of fire. The NEC specifies the methods for grounding and bonding different types of equipment, as well as the requirements for grounding electrodes and bonding jumpers. It is crucial to follow these requirements carefully to ensure the safety of the electrical system. Furthermore, surge protection is an important consideration for electrical installations. Surges, or transient overvoltages, can damage sensitive electronic equipment and even cause fires. Surge protective devices, or SPDs, are designed to protect against surges by diverting excess voltage to ground. The NEC recommends the use of SPD in certain applications, such as in buildings with sensitive electronic equipment or in areas prone to lightning strikes. When installing SPD, it is important to follow the manufacturer's instructions and the NEC requirements for grounding and bonding. Regular inspections and maintenance are also crucial for ensuring the continued safety and reliability of an electrical installation. Inspections should be performed by a qualified electrician who is familiar with the NEC and local codes. Maintenance should include checking for loose connections, damaged wiring, and other potential hazards. Any problems identified during inspections or maintenance should be corrected promptly to prevent further damage or injury. The NEC also addresses the issue of arc fault circuit interrupters, or SIs. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. When an arc fault is detected, the SI trips the circuit, interrupting the flow of current and preventing a fire. The NEC requires the use of SIs in certain areas of the home, such as bedrooms and living rooms. When installing SIs, it is important to follow the manufacturer's instructions and the NEC requirements for wiring and grounding. In addition to the NEC, local codes and regulations may also apply to electrical installations. These codes may be more stringent than the NEC and may address specific local conditions or concerns. It is important to be familiar with the local codes and regulations before starting any electrical work. Permits may also be required for certain types of electrical work. A permit is a document issued by the local authority that authorizes the work to be performed. Permits are typically required for new installations, renovations, and repairs. Obtaining a permit ensures that the work will be inspected and that it complies with the applicable codes and regulations. In conclusion, electrical installations must adhere to strict safety standards and comply with the National Electrical Code, local codes, and regulations. Using the correct type of cable, installing it properly, providing adequate fire protection, grounding and bonding the system, and incorporating surge protection are all essential for ensuring the safety and reliability of the installation. Regular inspections and maintenance are also crucial for preventing electrical hazards. By following these guidelines, it is possible to create a safe and efficient electrical system that will provide years of reliable service. Different editions of the NEC have varied requirements. When discussing the 1999 edition of the NEC, it's important to recognize specific stipulations regarding USE-2 cable and concealed wiring. This edition generally mandates that USE-2 cable, when used in concealed wiring applications, must be installed within a raceway. This requirement aims to provide additional protection to the cable, guarding against physical damage and reducing the risk of electrical hazards. A raceway, in this context, refers to an enclosed channel designed to hold wires or cables. Common types of raceways include conduits, tubing, and other similar enclosures. The purpose of the raceway is to provide a protective barrier shielding the wires from external factors such as moisture, abrasion, and impact. However, the 1999 NEC does offer an exception to this raceway requirement for underground installations. If the USE-2 cable is buried underground, it may not be necessary to install it within a raceway. This exception recognizes the inherent protection provided by the earth itself, which can help to shield the cable from damage. It's important to note that even in underground installations, the cable must still be installed in accordance with the other applicable requirements of the NEC, such as those related to burial depth and protection from physical damage. When working with electrical installations, it's crucial to consult the specific edition of the NEC that is in effect in your jurisdiction. The NEC is updated on a regular basis, and the requirements can change from one edition to the next. By referring to the correct edition of the NEC, you can ensure that your installation complies with the latest standards and that you are providing the highest level of safety. In addition to the NEC, local codes and regulations may also apply to electrical installations. These local requirements can vary depending on the jurisdiction, and they may be more stringent than the NEC in some cases. It's important to be aware of any local requirements that may apply to your project and to ensure that your installation complies with both the NEC and local codes. When selecting a raceway for USE-2 cable, it's important to choose a type that is suitable for the intended application. Different types of raceways offer different levels of protection, and some are better suited for certain environments than others. For example, if the raceway will be exposed to moisture, it's important to choose a type that is waterproof or water resistant. Similarly, if the raceway will be subject to physical damage, it's important to choose a type that is durable and impact resistant. Common types of raceways include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and rigid polyvinyl chloride conduit. Each of these types of raceways has its own unique properties and is suitable for different applications. When installing a raceway, it's important to follow the manufacturer's instructions and the NEC requirements for support and securement. The raceway must be properly supported to prevent it from sagging or becoming damaged. It must also be securely fastened to the building structure to prevent it from moving or shifting. In addition to the raceway itself, it's also important to consider the fittings and connectors that are used to connect the raceway to other components of the electrical system. These fittings and connectors must be compatible with the type of raceway being used, and they must be properly installed to ensure a secure and reliable connection. When working with electrical installations, it's always a good idea to consult with a qualified electrician. An electrician can help you to select the appropriate materials and methods for your project, and they can ensure that the installation complies with all applicable codes and regulations. Working with electricity can be dangerous, and it's important to take the necessary precautions to protect yourself from injury. Always disconnect the power before working on any electrical equipment, and use appropriate safety gear, such as gloves and eye protection. If you are not comfortable working with electricity, it's best to leave the job to a qualified electrician. Understanding the specific requirements of the NEC, particularly the edition in force in your location, is paramount. For instance, if you're operating under the 1999 NEC, you must adhere to its regulations concerning USE-2 cable and concealed wiring. This usually means encasing the cable within a protective raceway to bolster its safety and longevity. This requirement isn't just about following rules, it's about mitigating potential hazards and ensuring the electrical system's reliability. It's also crucial to keep abreast of updates to the NEC. The electrical codes are not static. They evolve to incorporate new technologies, address emerging safety concerns, and reflect advancements in the field. Staying informed about these changes is essential for ensuring that your electrical work remains compliant and safe. Moreover, understanding the rationale behind these codes is equally important. For example, the requirement for fire-rated cables or raceways and concealed wiring is rooted in the need to prevent fires and protect occupants. By understanding the why behind the rules, you can make more informed decisions and better appreciate the importance of compliance. Engaging with qualified electricians and electrical inspectors can also be invaluable. These professionals possess in-depth knowledge of the NEC and local codes, and they can provide guidance on proper installation techniques and materials. They can also help you identify potential hazards and ensure that your electrical work meets all applicable requirements. Remember, electrical safety is not just a matter of following rules, it's a matter of protecting lives and property. By taking the time to understand the NEC and local codes, and by working with qualified professionals, you can ensure that your electrical installations are safe, reliable, and compliant. And it's not just about avoiding penalties or delays, it's about creating a safe environment for yourself, your family, and your community. Furthermore, consider that even seemingly minor deviations from the NEC can have significant consequences. For example, using the wrong type of conduit or failing to properly support wiring can create hazards that may not be immediately apparent but can lead to problems down the road. A seemingly minor oversight can compromise the entire electrical system. Therefore, it's important to pay attention to every detail and to ensure that all aspects of the installation are performed correctly.